Okay, what we've got next is we've got a few symbol notations that we're going to use along with a couple new definitions in these next couple videos. So the first one, we already defined what an element is, right? It's something that's in the set, but we have a symbol to denote it. So the symbol, it looks kind of like, sort of like an E, or it's sort of like a capital C with a line through it. So that symbol means is an element of. If we want to indicate it's not an element of, we just put a slash through it, which is kind of what we're used to. So like not equals, for instance. So we're going to use that practice all the time. So anytime you want to say is not blah, just put a slash through the symbol. So a couple examples of what that could look like. We could have something like, well, 1 is an element of the set containing 1, 4, and 9, right? Literally 1 is amongst the elements listed in that set. But something like 1 is not an element of the set containing like 2, 5, and 16. Notice there is literally a 1 that was written, but it's not the digit 1, it's the number 16. 1 itself does not show up in the list of those elements, so it's not an element of that set. So there's some examples there for that. Our next definition that we have is going to be fairly intuitive, hopefully. It's talking about two sets, A and B, are equal, which we're just going to use our standard equals sign for that, A equals B. If and only if, so our definition for this, hopefully it kind of makes sense, right? If they're going to be equal, they need to be basically the same, and the thing that defines sets is their elements. So two sets A and B are equal if and only if they contain the same elements. If and only if they contain the same elements. Now, this brings up an interesting point with sets, that essentially the only thing that defines a set is what is an element of it and what's not an element of it. So a few things that are interesting in terms of set notation is the order the elements are written in really doesn't matter, because all that matters is what's in it and what's not in it. We wrote it on the board last time, but didn't make a big deal about it, that if we are doing roster method, if we're listing the elements, we only list a particular element once. Because again, the only thing that matters is it in there or is it not in there? It doesn't matter if it shows up multiple times. So if I look at this next example, we could ask the question, true or false? A equals B. Well, A is the set containing 1, 3, 7, and 9, and B is the set 3, 1, 9, 7. So the elements are out of order, but if we check, 1 is in both, 3 is in both, 7 is in both, and 9 is in both. So they do contain the same elements, so this would be true. So those are two equal sets. Now, those ones were both already in roster method. Let's look at this next example where we have one set that's a verbal description and one set that is in roster method. So the first one says C is the set of all digits in the year Sterling College was founded. So kind of a fun fact trivia question if you can think about it. You can pause the video even and look it up, or just share your infinite knowledge. Sterling College was founded in 1887. So if we think about what that set would be, we could rewrite it in roster method, where notice it was 1887. So there's a 1, there's an 8, there's another 8 because it's 1887, but I don't care to write it a second time. The only thing that matters is that 8 was in the set. So it's a 1 and 8, and then I still have a 7. So notice we only write that 8 once. Now if we compare these to 187, the set containing 187 is the same as the set containing 178. Because again, I don't care about what order. The elements are written in, just the fact that they have the same elements. So we do in fact have that C equals D in this example. You can go ahead now and again stop this video and pull your worksheet for section 2.1 out again, and you'll try that next example in it. Again, try it first and then start the next video to see the solution for that example.